Have you ever seen that little horseshoe-looking light on your dashboard and ignored it? Did you know that behind that warning symbol is a tiny piece of electronics inside your tire, a sensor that could be doing the difference between a quiet drive and a blowout? In today's video, we're going inside the tire pressure sensor, peeling back what it's made of, how it works, why it matters, and the hidden tech that you probably drive over every day without thinking. So buckle up, because we're about to explore what's really inside your tire's monitoring system. Here are some questions to keep in mind. What happens inside the wheel when you hit a curve, and how does the sensor survive that? How does the sensor send a signal from inside a rotating, air-filled tire to a receiver in your car? Why do some vehicles show exact tire pressure, and others just give you a warning light? And finally, when that TPMS light comes on, is the sensor broken or is it just the battery life running down? We'll answer all that and more. First, the system we're talking about is called the Tire Pressure Monitoring System, or TPMS for short. There are two main types: indirect tire pressure monitoring system. TPMS uses wheel speed sensors, the same ones in ABS, to detect when a tire is underinflated because it has a smaller diameter and spins faster. Direct Tire Pressure Monitoring System (TPMS) has an actual sensor in each tire that measures the air pressure, and often temperature, and transmits the data wirelessly to the car's computer. Our focus today is on the direct type, what's inside the sensor that lives inside the tire rim. Let's imagine we crack open one of these sensors. What do we find? According to technical sources, a typical direct tire pressure monitoring system sensor includes a pressure transducer, often a MEMS chip, that detects the air pressure inside the tire. A temperature sensor, optional, but common, to measure tire temperature because it affects pressure. An analog to digital converter, ADC, to turn that pressure reading into digital data. A microcontroller to process the sensor data and decide when to send a message. A voltage regulator, power management circuit tied to the internal battery. A radio frequency, RF, transmitter, usually around 315 MHz in the US or approximately 433 MHz in Europe, to wirelessly send the pressure, and sometimes temperature, reading plus sensor ID code to the vehicle's receiver. A battery, typically non-serviceable, sealed, designed to last many years, 7–10 years typical, given the harsh environment and limited maintenance access. A housing, valve stem assembly, rubber grommets, seals to keep air pressure and moisture out. Each component plays a critical role. The pressure transducer senses the key variable. The microcontroller and transmitter do the reporting job. The battery provides power inside a rotating, inflated tire. The housing ensures durability. So how does it all come together when you're driving? Here's a step-by-step. 1. The sensor, mounted on or near the valve stem inside the tire, continuously, or periodically, monitors the air pressure inside the tire cavity. It may also monitor temperature and sometimes rotational speed, acceleration, to know when the vehicle is moving versus parked. When the pressure drops below a threshold, or when the system is commanded to wake up, the microcontroller triggers the RF transmitter. The transmitter sends a data packet that includes the sensor's unique ID, pressure reading, temperature reading, status information. The vehicle's TPMS control unit receives this, figures out which wheel it came from, via ID, signal strength, or learned location, and displays pressure or warning to the driver. If the pressure is more than approximately 25% below the manufacturer's recommended pressure, a regulatory threshold in the US, the warning lamp is triggered. Because the sensor sits inside the tire, it must survive huge variations, high rotational forces, temperature extremes, seal integrity under pressure, vibration, ingress of mud, water, and the need to function reliably for years. That's why design and materials matter. Now let's talk about what can go wrong, why your TPMS light might come on even if your tire seems okay, or why changing tires sometimes means replacing the sensor. Some common failure modes. Battery life. Because the sensor battery is often sealed and non-serviceable, once it nears end of life the sensor stops transmitting properly and must be replaced. Valve stem, seal corrosion. The sensor is mounted via the valve stem. Corrosion or damage to the stem, grommet can cause air leak or sensor failure. RF transmission, ID conflict issues. If a sensor is replaced and not relearned by the vehicle's TPMS controller, the car might not recognize it or could misidentify the tire. Physical damage. Hitting a curb, high-speed spinout, or improper tire mounting can damage the sensor. Seal, pressure leak issues. The mounting area must remain sealed. If the sensor housing or grommet leaks, the sensor may fail or allow slow deflation. Aftermarket interference. Using sealants, aftermarket wheels, or wheels without proper TPMS support can interfere or shorten sensor life. Here are actionable tips you can use if you own a vehicle with TPMS. When you get new tires or rotate tires, ask the technician to inspect the TPMS sensors, grommets and valve stems. If your TPMS sensor battery is old, sensor age 7 to 10 years, consider proactive replacement. It can save you from a surprise warning light or failure. After a sensor replacement, ensure the sensor is properly programmed learned by the vehicle so the correct wheel is identified. Avoid cheap metal valve caps with no insulating liners on TPMS stems. They can exacerbate corrosion or sensor damage. If your TPMS light comes on, check tire pressures manually first, using a quality gauge. Then if pressure is correct and light persists, the sensor or system may be at fault. When using aftermarket wheels or changing tire sizes, be aware. Indirect TPMS systems may be less accurate, and direct systems may need sensor adjustments. Why should you care about what's inside this tiny sensor? Because the TPMS isn't just a convenience, it's a safety and efficiency tool. Proper tire pressure improves braking distance, stability, tire wear, and fuel economy. For example, underinflated tires can overheat, wear faster, reduce fuel mileage and even lead to blowouts. The TPMS gives you a heads up long before it becomes dangerous. Also, when you understand what's inside, the electronics, the battery, the transmitter, you're better equipped to spot when something's going wrong, instead of simply ignoring the warning light. Thanks for watching. If you enjoyed this peek inside the tire pressure sensor and learned something new, please hit like, subscribe, and share this video with friends or family who might still think that TPMS warning light is just a nuisance. Stay safe on the road, and keep those tires properly inflated.